Welcome to the anatomy of the square root, a journey from fundamental definitions to high-precision algorithms. The square root is the mathematical inverse of power. Squaring, like 5 times 5, gives 25. Rooting 25 extracts the original number, 5. The square root is defined as the value that, when multiplied by itself, returns the original number. There is a duality of roots. Both positive 4 and negative 4, when squared, result in 16. However, calculators return only the principal square root, which is the non-negative value, or modulus. Roots can be categorized into 3 types. Perfect squares result in integers. Irrational roots result in non-terminating decimals. Complex roots arise from negative inputs, resulting in imaginary numbers. For non-perfect squares, finding the root is a challenge of precision. Instead of guessing, we utilize modern iterative algorithms, like Newton's method, to converge on the correct value. The engine for precision is Newton's method, also known as the Babylonian method. This formula refines an approximation by averaging the current guess with the target number divided by that guess. This method provides quadratic convergence. To visualize the algorithm, let's find the square root of 50. Starting with 50 as our guess, the first iteration dramatically reduces the error to 25.5. The second step further refines this to 13.73. The process shows rapid convergence. In just 5 iterations, the rough initial guess of 50 achieves a high precision value, closely matching the target root of 7.0710678. Square roots follow key mathematical properties. These include the product rule, which allows you to separate the square root of a product, the quotient rule for division, and the power rule, which results in the absolute value of the base. A common misconception is the sum property fallacy. The square root of a sum is not equal to the sum of the square roots. This can be visualized using geometry, where the sum of 2 sides of a right triangle is longer than the hypotenuse. Square roots have broad applications, particularly in measuring space. They are fundamental to the Pythagorean theorem for calculating hypotenuses, pathfinding, and reversing the area of a circle to find the radius. Roots are also vital in physics and engineering. They are used in electrical engineering to find the root mean square, in statistics to calculate standard deviation, and in physics for determining the period of frequency and resonance. The MiniWebtool calculator is designed for this task, offering extreme precision up to 1,000 places. It supports scientific notation and complex numbers, and includes educational steps for visualization. The key takeaways are: the square root is the inverse of squaring. Results can be categorized by a taxonomy. Newton's method provides the engine for high precision, and its utility is foundational to geometry, physics, and statistics. You can calculate with precision using the MiniWebtool square root calculator. It is a free, high precision, and educational tool.